Hey everyone, I finally analyzed all 160 scans and started to get some sort of overview analyses of it, and I wanted to share that with you. I'm really sort of happy to reach this sort of benchmark. I was determined to finish the 2023 LiDAR scans before going off in July to collect the 2024 scans along with Maddy. Maddy's actually making scans of mangroves in Florida, and in fact, Eric just returned from Indonesia where he was making scans of the rainforest there. So our lab, the Ecology with No Apology lab group, has been doing an awful lot with these portable scanners, and I'm excited about being able to get information about the sort of structure of the vegetation. And out at Toolik Lake, it's been interesting because it's such low-lying vegetation, and yet it matters a lot to the biogeochemistry of the place and to the future of the system as climate is changing. And so let me share with you some of those results. And just as a reminder, there are 4 blocks for the moist acidic tundra O6 experiment. And over on the left, you can see scans have been all stitched together or registered for the 4 blocks. I use all 4 blocks. We don't always use block 4 because it seems a little anomalous. But as long as they're data, I include it. And then the scanning software can create 1 meter cube segments of each of the scans. And I've taken 4 1 meter cube segments for each of the treatment plots in each of the blocks. So that's, quadrats, if you will, times 10 treatments times 4 blocks. So that's where the 160 comes from. And then here just shows you on the bottom the 4 1 meter cubed segments out of the vegetation plot. And then over on the right, it shows you the R analyses plot. And I think if you squint, you can sort of see that it looks like a forest, but it's a it's not a it's not a bunch of trees being taken pictures of or scans from an airplane. But if you squint, you can sort of imagine it's a forest, right? Except what we have is a scanner on a tripod about 3 feet, 3 feet or 3.5 feet above the vegetation. The sort of squares that you see there comes from my attempts to create a ground layer, but I can explain that later. Here are some of the variables in a correlation plot that one gets from this. Now, the variables have to do with sort of the architecture based on the point cloud. There are a lot of tree metrics that come out of LiDAR scans, which we're not going to be able to use here. There's no diameter, breast height. We don't really have things like, the mean branch length or the mean branch density or branch complexity or things like that, because there really aren't, except for the tiny. Actually, there really aren't any. It really isn't any branch trunks at diameter. But, if you look at the point cloud, there are lots of architectural properties of it which are interesting, such as the roughness of the canopy, the surface, the volume of the canopy, and other sorts of measures that you can make using the LiDAR or LiDAR, LIDR package. Now, that package is designed for aerial scans done at meter scales, and I contacted the developer of the package who kindly wrote back and said there's no problem at all to change things to working with centimeters. He said it's not scale dependent. He said, you could go up to a kilometer if you wanted or centimeter if you wanted. So that was encouraging, and I went and changed everything so that it was running on centimeter scales rather than meter scales. And it worked fine, or at least there was output, and it looked plausible that it was providing interesting output. And so here you are. And then all of these variables, not surprisingly, correlate with one another. So some of the different architectural measures are positively correlated, which is the blue. Some are negatively correlated, which is the red to the orange. And one of the variables in here is not from the scans. It's the number of grams of nitrogen that was added per meter square in the plots. And I just wanted to throw that in to see how it is associated directly with these architectural measurements. It's a little crude because it's something that was sort of scattered over the plots as opposed to these more precise measures. But you can see that there is some negative correlations with some of the architectural measurements, and there are some positive correlations. That's really nice. That really shows that, there is an association um, nitrogen being manipulated and the response of the vegetation by the sort of point cloud architectural measures. So super cool. Now, if we look at the principal component analysis, which is the approach, one of many that one can take when you have lots of correlated variables to try to go through what's called data reduction and reduce it to a number of variables which capture most of the information that the many variables, in this case here, the 10 different variables actually capture. And it was quite successful in the sense that it identified one complex variable, which captures 45% of the information inside the data. And then the second variable that it comes up with captures less, but it captures 45%. And the third is about 10. If you look at it all told, this is about 75 to 80% of the information in the cloud of data that's driven by 10 different measures, so that we can actually have an easier time of interpreting it and not worrying about the fact that some of these are correlated either negatively or positively with one another, and focus on what really is driving the differences here. And the results you get are these pretty plots for a person who likes multivariate statistics. I just find the aesthetics of these things always so appealing, even if ecologically they're not important. Because if after all, you're going to be a community ecologist, a lot of times the one thing that you can at least get out of this is something that's aesthetically appealing in terms of analyses, even if it's meaningless otherwise. In this case here, we have both. I think we have the aesthetic appeal as well as some possible meaning here. You'll notice that these vectors tell you which way the data points are being driven with respect to this bivariate plot. And some of them you can see are being driven to the right by this vector here, which is the number of grams of nitrogen added per meter square. Now, if you look at the other vectors, you'll see that many of them are stronger than that one. And so, in fact, depending on what your cloud structure is, you'll see that you're being driven to the right or to the left, mostly to the right and up and down than you are to the left. And you can see the treatments are in the legend here. There's the control, the different levels of nitrogen that were added. And over here is the F10. And way over on this side is sort of clustered the control in which nothing was added. And then the the point 5, half gram, and then the gram, and then 2 grams. So really, I would say there's probably 3 significant clusters because these are 95% confidence ellipses around the center of the quadrats which were taken. Okay, I know there's, I know that there's pseudoreplication here, but I'm not doing hypothesis testing. I'm just simply looking at the patterns. But it does mean that if we try to do some sort of GLM or analysis of variance, we're going to have to be aware of the fact that 4 of the quadrats were inside each of the blocks, and then each of the treatments, and each of the treatments were only one per block, and there's only 4 blocks. And if we're not using block 4, we only really have 3 points. So it's going to be hard to make sense of it. You might be wondering, what about those other treatments? I did not include them, but of course they're there, and we will include them in other kinds of analyses. H is the herbivore, NH is where we added ammonium and phosphorus, and NO is where we added nitrate and phosphorus, I believe that's, if I remember correctly. X is the extra. It kind of functions as a control, much as H does. The problem with H is it has the greenhouse on it, which casts quite a bit of shadow in different directions as the sun goes around. But the X is kind of like a control, and that nothing was added to it. Um, and you can see that when we do that, that most of those extra treatments are all sort of, overlapping with the low nitrogen or the control over on the left. And it's angled the nitrogen influence down a little bit, but you can see that the overall pattern still is there. You tell me how much nitrogen was added to that plot, and I can tell you something about the differences in the architecture of the vegetation that you will find there. All right. Now, as a community ecologist, my ultimate goal is to show that the only thing that matters at Toolik Lake is biodiversity. Of course, in conjunction with other people that everyone is measuring, but I want to be able to take vegetation as measured by the percent cover from the pluck as well to relate how the diversity of the species, either taxonomically, functionally, or phylogenetically, meaning the evolutionary diversity that are in the vegetation within each of those quadrats, tells us why we see some of the system level properties that we're finding, such as the architecture. For example, the roughness of the canopy and the height and the variability in the structure can tell you a lot about photosynthesis when you have the atmosphere moving over this particular structure. Of course, it depends on the different plants that are inside that cloud and also in their differences in function and evolutionary history. But that's coming later. One of the it'll be maybe two or three of the 18 papers I'm supposed to write on my sabbatical, or Sarah Bruner's going to write it. But I'm excited about having reached this benchmark, and I will not be playing with this anymore since I have to get ready to do other things this summer, including heading out to Tulip in July with Maddy. Okay, thanks everyone. Have a great summer. I'm sure what you wanted more to do in your summer was to see a PowerPoint video. Take care, everyone. Bye bye.